I'll give small diagram so it'll be easy for us. The ball is projected with a speed u. It will move in a parabolic path. Okay, fine. So what will happen to wedge after some time? When the ball is moving, the wedge will come to this position. So where it will strike the wedge? So this was the point B, no? So it will strike at point B. It will move in a parabolic path, not a straight line. It will move in a parabolic path. So here was that point B. The A will be here only. A will not shift. The wedge will continue to move with its velocity. I think this diagram, what I given is enough. So what is this red color? Path of the particle. Sir, it will move in a parabolic path here like this. If you are standing on wedge, but on the ground, path of the particle with respect to ground, a person standing on the ground. What he says, particle moves in parabolic path, wedge moves horizontally. See, this is very important. So what is an particle moves in parabolic path and wedge moves horizontally. I think these comments are very important. So write down all the equations, everything finish for. It didn't ask like a time of flight to strike the ground. Time taken, find the time taken by the particle to strike the wedge. So this is t equals 0. This situation is t equal to 0. This situation is what? The time. So don't call time of flight. Time taken to move from A to B. Not time of flight. Time of flight means directly you know formula with respect to ground, you can calculate time of flight. Okay, how to bring this? No. With respect to motion of the wedge, what happened? We have to describe the thing that one. So let's resolve the velocity of the acceleration due to gravity. How much it should be? Anybody, how much acceleration due to gravity? G sine 30, G cos 30. And already this velocity is perpendicular to incline, no? This is. So finally what happens? Strike it is. So when the particle moves from in the wedge frame, so I'm directly jumping to in the wedge frame. In the wedge frame. Or in the wedge frame, in the moving wedge frame, in the what is the finally it will strike at B, no? So what is the displacement perpendicular to incline? Displacement final separation minus initial separation is equal to velocity of particle with respect to wedge plus acceleration of particle with respect to wedge t square by 2. What is it finally? It is at point A. And finally, what happened is at point B. What is the displacement perpendicular to incline? Will be 0, no? Final separation. Final perpendicular separation minus initial perpendicular separation. Velocity of particle. So let me take this direction as positive. Velocity of particle. How much it should be? 10 root 3. Velocity of edge. I should resolve that velocity, no? So how much it will be? 10 root 3 sine 30. plus acceleration of the particle. What is the acceleration of particle perpendicular to incline? Minus g cos 30. Acceleration of which? Acceleration of incline, I think is moving with constant velocity. That will be zero, no? Maximum students are, you have to write equation. That's all, no other way. See, where all relative motion, relative accelerated motion, I'm bringing that one. Whatever the thing, the basic formula. So solving this, we'll get the time of flight, 2 seconds. Okay, this will be our answer. Now, what is this T you should call? Time taken to move from A to B, it is. Not that one. So if you want TAB, you can write it. So let me, in the end, I'll write it here. Okay, now find the range on the wedge. It's asking the distance AB, range along the incline. In the moving wedge frame. So here in what action we applied this formula, perpendicular to incline, no? This is. No, parallel to incline will apply it. Wedge is at rest. Wedge is moving, no? Moving wedge, why you are not understanding the question? Wedge is moving, oh no. Why the wedge is at rest? Wedge is moving. Wedge is moving horizontally. No, the distance range along the incline, SAB. If the wedge is at rest, then how will the ball? I don't know, like you are unnecessary, that question itself. It's wedge is moving, then why you are making it rest? SAB. Let me finish off this, then you can clarify it out in the end. SAB. So along the incline, the range along the incline. What is the formula again? Velocity of the particle with respect to wedge into T plus acceleration of particle with respect to wedge. This one along the incline. This again, don't substitute same values. Along the incline, we have to substitute this value. So now what are the, this is unknown thing. We don't know this. LHS. No, come for one by one. Okay, this U parallel, no? This is, I think some of you are getting confusion. I'll do one thing. Perpendicular. Okay, fine. This is perpendicular. Some of you are asking, sir, P, what do you mean by that? So similarly here, I'll change the value symbols. U parallel velocity of calculate, no? So let's go for U parallel minus W parallel T. A parallel minus W parallel T square by 2. So what do you mean by parallel? This is the parallel. This is the perpendicular. Okay, substitute all the values. Velocity of the particle along the incline will be 0, no? Because this is 90. Velocity of the wedge along the parallel. So should be equal to how much? U cos 30. So this angle is 30, no? And it's left to you. I'm taking this direction as positive. So this should be velocity. This should be U plus time of flight. Okay, then A parallel. Velocity of particle parallel to incline. Shall we write G sine 30? And how much it should be? It should be in this direction. This should be positive. What is the velocity of acceleration of wedge along the incline? Will be zero, no? Wedge is moving with a constant velocity. So this is what? SAB. So SAB is equal to minus U. U is how much? 10 root 3. Root 3 by 2. Time of flight 2. Plus this will be 10 by 2. T square, 2 square by 2. Anybody value? Minus 10.
Minus 20. 25, sir.
Look at once. Minus 20.
Minus 20, sir.
Minus 20, sir.
What do you mean by minus 20? We took direction down the incline positive, no? So therefore, it'll strike at point B Stirling. I'll write indeed.